Thank you everybody for taking this time out of your valuable Friday afternoon. We're going to be talking about web editing with the ArcGIS API for JavaScript. My name is Bjorn Svensson. I'm one of the product engineers on the JavaScript API team at Esri. And with me today I have Franco.
Hi, I'm Juan Carlos Franco. I'm a software developer with the JavaScript API.
I'm Jonathan Uline. I'm also a developer with the JS API.
All right. We'll talk about web editing. We're going to talk about the editor widgets, some other widgets, and then you guys ask questions. Number 4, please. Thank you. We can't see them from where we're standing, so we depend on you guys. But I said everything, and now we're moving on. When we talk about editing, we really want to have the data in a feature service. And a feature service can be either one feature layer or it can be multiple feature layers. The other key aspect, if you want to edit it, is that it's actually editable. Oops. When you use the Esri tools, the technology on the web to edit, really the way it's working is there's a REST API that sits on your feature service or your server. And then whether you use ArcGIS Online, Python API, Runtime, or JavaScript API, they actually all go through the REST API. And Python and JavaScript just make it easier for you to work with the REST API. Oops. So one of the things when you have a service, oh, sorry. Let's go in order. All right. Web editing in the browser. Over the last few releases of the 4X API, we have been releasing functionality to make it possible to do editing. Some of those is if you want to add things, you want to use feature templates. For geometry, you want to be able to edit things, move the draw the feature or modify the geometry on it. The third thing is you probably have attributes in your data, and that could be fields, attributes, and we use the feature form to display that. All of these things, then to make it actually being saved on the server, you would use our feature layer apply edits method, which then calls into the REST API and things happen on the server. In the 4.11 release that's about to happen in 3 weeks, minus 1 day, we have an editor widget, and that's what I'm going to show and talk about today. And then we're going to talk more about some of these other ways of doing custom workflows. Now, I talked about in the first slide how you want to edit data that's editable. If you have a hosted feature layer or an enterprise, if you go to your settings, you can scroll down, and you see one of the key things here is the enable editing. Now, you probably already know that, but there's additional functionality. And I talk about this because a lot of the things that you might want to specify to the user, you want to keep track of users, you want the user to only edit attributes or only geometry. While you can lock that down on the client, you can also lock it down on the server. So it's easier if you do it on the root. So for example, if you want to track people and you want to allow people to only edit the features that they created, you set this up, then the API will abide by this, and it's just going to work perfectly. All right. In this application, I have an editor widget. It's a very simple. I'm going to show you the code, and basically all the code for adding an editor widget are these 2 lines. This is the default. There's no property set and methods. What happens here is basically the editor widget will look what layers are editable. So if you call in for a web map, as in this case, or if you're adding layers manually, either way, it looks in the service, in the map, and see what's editable, and then it works with those. In this case, I have 2 layers in my web map. There's a point layer and a line layer with some dashed lines that are hard to see. The first thing you might want to do is to add new features. So I'm clicking Add Features. I decide which feature template and what type of feature I want to create. I can either scroll down, or if I want to quickly find it, I can just filter it, typing it in. So there's a robbery here. You fill in some valid data. You scroll down, fill in all the fields. Some of these are domain values that have been set up on your server. And some of them are strings, some of them date things. I can say this is an active issue. There's an active robbery going on. And I can save it. Now if I want to add more things, I just click robbery again and I keep going. And then I have my data. The second part you might want to do when you have features that are already created is using the edit feature flow here. I select the feature I want to edit. It can be a line. I can change whatever is changeable on this, or I can change the geometry. Resize it, or more likely you click on it again so you can change the actual things. I can add more nodes. If you use the free ArcGIS API, there's nothing new. Most of the basic principles are the same. One of the things that's a little bit new is that we have options for how to draw them, that we have a little bit more. We have more options for how to draw them than we did in FreeX. And of course, you can delete features as well. And that's our editor widget. Now, the editor widget itself comes with a number of properties you can change and methods, so you can customize a little bit just using the API. But there are times when you want to work with the components that make it up. Maybe you want to work directly with the feature form or some of the other components. And that is what Frank is going to talk more about.
Thanks, Bjorn. So for the following slides, Jonathan and myself are going to be covering custom workflows, meaning taking, like Bjorn said, some of the components that the editor uses and using them separately. If you didn't, for example, want to use the editor out of the box UI, or you wanted to cater to your own design. So that's what we'll be covering. And for this section, I'll be focusing on the form-based sort of workflows. Oh, sorry. Yes. 5. Thank you. So for the next section, I'll be focusing on form-based, and specifically, I'll be using the feature form, which the editor makes use of. And if you're not familiar with a feature form, this is simply a widget that whenever you give it a feature, it will render input fields based on the attributes. And once you give a feature to the widget, what's going to happen is it's going to look up the layer where this feature belongs, and then going to make sure that based on the types of the fields, based on those types, it's going to provide the specific inputs. For example, if you have a field of type number, it's going to display a numeric stepper. If you have a date, you look at a specific UI for filling out the date and time, etc. If you also have domains, it's going to automatically provide a select for you with the available and supported values. And another pretty neat feature is that it allows you, it's pretty flexible. We're trying to make it as flexible as possible. And some of the configuration options that you have by default is you can, if you want to specify a different order of the fields from what the service provides, you can go ahead and do that. If you wanted to rename or provide more useful hints for filling out the individual fields, you can go ahead and do that as well. If you want to provide a much more clear structure of how different fields relate to each other, you can use the grouping. And coming in the next release of the JavaScript API, we're going to introduce conditional visibility, meaning that you can define an arcade expression that determines whenever an input field becomes visible or not in your UI. And I'll show that in the next demo. So what I'll be doing here is showing this very simple application to report coyote encounters. And I'll walk through how this application is set up. But once you refresh, it's just going to pick a random feature and then pass that along to the feature form. And then it's going to render all the individual fields based on the workflow that I described. And for example, I can also go ahead and select one, make some updates. And once I submit the save, if I try it again, it's going to display that updated value. And this is using behind the scenes the feature form and calling apply edits on the associated feature layer. So before we show the different options, I just want to go quickly through the application structure. And this is my index page, and I'll just call out the notable pieces here. So first of all, this is where I'm requiring my application. And for the DOM, I'm just defining a div for the view and a container that will have my feature form and a button to submit my updates. If I go into my application, all that I'm doing here is creating a feature layer for that Coyote encounters data, and then setting up my view. And I'm just disabling the pop-up by default because as soon as I click on a feature, I want that to be passed to the feature form directly. And as soon as you click on the view, if we have anything that's selected, we're going to unselect it. And afterwards, we check whether there was a graphic underneath the click. And if so, we're going to select it and pass it to the feature form. When we select a feature, all that it's doing is querying the feature layer for the full geometry and the attributes. Sorry, specifically we're focusing on the attributes here because we want to make sure that all the values that are shown in the feature form are the latest. So whenever that happens, this is where we actually pass it to the feature form. And afterwards, we're just going to highlight it on the map. So I'm going to scroll here to where the form is actually set up. So you can see it's pretty straightforward. I'm creating a new feature form and passing a reference to the DOM node where it's going to be displayed. And whenever this form fires a submit event, we're going to get the latest values that the user entered and just call apply edits on the feature layer. If I take a look at that method, all that we're doing here is calling apply edits on the feature layer with the graphic that I updated. And once it's done, it's going to highlight the feature again. Cool. So if I go back to my application, you will see that by default, without any configuration, it's showing the name for each one of these fields. And by default, it'll try to look at the alias defined on the field. And if there's none defined, it's just going to fall back on the field name. And what I can see here is that these names are kind of, they could be better, right? Because there's inconsistent casing between them. For example, encounters all uppercase, verified is not. And date of encounter, you need, if you don't know what that field is, it's kind of tricky to know what that represents. So, and in the bottom here, we have an internal ID, which maybe not, it may not be necessary to show to the user. So let's start off by providing kind of better names for some of these. So I'll go back to where I created my form and provide a set of field configurations. And all this is an array of field configuration objects. And in this case, we're passing the name of the field as well as the custom label. Another cool thing is that if you have a typo on one of your fields, you can override it. So if I refresh here, that's fine. Okay, thank you. So now if my code compiles, if I refresh, we should see better labels on these different fields. So now it's clearer. This is the date of the encounter. And looking at this last field, it's not necessarily, I don't really want to show it to my user. So what I can do is, actually, sorry, before I do that, I can also, if I'm not happy with the default order, I can just by moving the order of these fields, it's going to display a different order. So you can change the order. based on the configuration. So in this case, I swapped encounter and location because I thought encounter is really the type for this report. So I want to make sure that it's the first thing that we see. So just by messing with the order of these configurations, you can get them to render differently. And going back to what I was saying about hiding the internal ID, just by omitting it, it'll just exclude it from being rendered in the UI. So if I go back, refresh, we should no longer see it. So no more internal ID. So that's cool and everything. But you can also provide custom description for some of these fields. I mentioned that encounter is really a type. So what I can do here is provide a description with a little bit more specific, this more specific label and kind of a better hint at how to fill it out. So now my field will display a little hint here saying that this value should be either encounter, citing, garbage, or feeding. So that's nice, but it's also error prone because it requires the user to actually read that description and to have the user avoid any typos. So what I can do here is, since that's a string field, I can specify a set of options for the user to select from. So I can do that by providing a custom domain for it. In this case, it's going to be a coded value domain that I'm just calling encounter types. And it's going to have the following coded values. So I want to display these as the only set of options that the user can set. So just by providing this, if I refresh my application, instead of getting an input of a string input, now I get a select that allows the user to provide one of the options that I require. Another thing is, if taking a look at the last two fields that we have here, verified and reviewer are more for the intent is to be filled out by the people that are actually doing the reviewing and not necessarily the people that are reporting it. So what I can do here is mark them as not being editable. So by playing with the editable flag, I can prevent them from being input. So now my reviewer and verified fields are disabled. And I mentioned before that you can also group the fields. And if I go back to my form, type, location, and date of encounter are more associated to, in general, to the encounter. And verified and reviewer is more like related to the status of it. So by using groups, I can make it clear in my UI that I have two different sets of fields to display to my user. So all I'm doing here is defining the two groups that I mentioned. Oh, I forgot to. Sorry, need to. What's wrong? I'm getting an issue here. Oh, I think I know. Oh, there we go. Fixed. Sorry about that. I'm missing a comma here.
Who can spot it?
There we go. Sorry. This is live. So what I have here are two groups. As I mentioned, I want the first one to reflect that there are general information, and I will provide a label and description for this group, as well as the fields that we mentioned earlier, encounter type, location, and date of encounter. And for the second one, we just want to group them in the status group. Same thing, label and description with the fields. Now if I refresh, we'll get the two fields, the two groups shown. And by default, the form will display all groups expanded. But you can also, if you wanted to kind of keep the UI cleaner, you can tell the form to only display one group at a time. And you can do that by using an option called group display. So by default, it is set to all. And in this case, we want to show one at a time. So by changing that, now only one group is open at a time. If you set a field to required, the question was what happens if you set mark a field as required. If the service defines a field as not being required, you can override that with a configuration and make it required in the UI, but you can't do the opposite. So that's another option to kind of cater, fine-tune your form experience.
What's the visual thing? Can you still submit it?
You'll get a visual indication if a field is marked as required and it's not filled out when you focus out of it.
So the question is, can you get it from the coded values from the service? Is that correct?
Yes. The answer is yes. By default, the feature form, if there's a domain defined on a field, it'll use it. But in this case, the field that I configured with a domain didn't have one, so I just provided one.
Another use case, it might be set up in English and you want to provide it in a different language like Swedish. You can overwrite the domain values on the client. But normally you should be setting it up on the server correctly and things will be right if you have the controls.
Okay, so moving on to wrap up, the last thing that I mentioned that the form supports is in the next release, you can provide an arcade expression to conditionally control the visibility of it. So for this example, for the location field, I only want to show it when the encounter is of value garbage. Not very useful, but it'll work for this sample. So if I go back to my form, we should no longer see location when the type is encounter. But when I change it to garbage, we get location displayed. Again, this is all to kind of keep your fields clean and only show them to the user when they're applicable. So with this, you kind of have the foundation for a very form-focused application. And if you wanted to take it further, you can end up with something that was just shown in the plenary, such as the report bike theft sample, and where you can wire it up with a search widget and then have it pick up a location, and then with a feature form, conditionally show different fields and allow you, in this case, to report a bike theft incident. Cool. So with that, I'll pass it along to Jonathan for geometry-based editing.
Thanks, Franco. So we're going to talk about the sketch widget today, both the sketch widget and the sketch view model under the hood. If you're not aware, the sketch component is really what drives the geometry manipulation of the map, both creation and updating. The view model, sketch view model, I believe, was released in 4.5, and the widget itself was released in 4.10. And just to recap, Sketch provides the ability to manipulate geometries on the client side specifically. So everything is done via a graphics layer on the client through your page. And it's highly configurable. What this means is you can configure the tools that you want to use to create and update your geometries. For creation, this might mean if you want to do a freehand pen tool so the user can actually write some things on the map, you can force them to do it that way. Or maybe you want to only add vertices on click. So it's a very specific workflow where I'm going to click and then a vertex is added rather than some sort of freehand model. We also provide a hybrid that allows both clicking and dragging to create vertices. On the update front, maybe you want to disable things like rotation or scaling or reshaping vertices. You want to lock vertices in place and prevent that. Those are the kind of configurations you can do via the widget and the view model. That last bullet point as well is this kind of really neat helper mechanism that Sketch View Model provides, where as long as you pass it a graphics layer, which is a required thing, whenever you attempt to click on the view, if the graphics layer is added to the view, it will check if a graphic that belongs to the layer that is passed to Sketch exists, and it'll automatically initiate the update workflow. What this means is it basically allows you to not have to write a block of code that you have to interact with the view to target specific graphics. So we kind of do that for you under the hood. You can opt out of it if you want to do your own, manage your own update experience. You want the user to be able to click on the map but not automatically enter that update workflow. So you can customize it in that way. The 4 demos we're going to look at today are pretty varied. The first 2 are similar enough, and actually we're going to look at them in the reverse order than the slide here. We're going to look at the demos, and we're going to look at the code right after the demo itself, so you can see what I'm actually doing under the hood. So the first thing we're going to look at is our first sample here. So this is a sample that is using Sketch View Model under the hood, so we're not using the actual widget, we're using the underlying logic that the widget uses to create geometries. So in this app, I have one single button with a polygon icon, and what it ends up doing is when I click this button, it allows me to create a polygon. So I'm gonna go ahead, click around, finish my polygon, and what happens is you'll see it disappear. What happens is it's doing a apply edits to the service, and it's removing it from the graphics layer because we're done. We don't care about the graphic at the client level. And when the layer finally refreshes and gets that update, it displays it using the layer's symbology. So this is a very simple custom app. Like, hey, I don't need the editor. I don't need the Sketch widget. I don't need all the full-blown capabilities or tools that are provided out of the box. I just want to be able in my app to draw a polygon around something and it save it, and that's a really simple interface. So what is actually happening under the hood in this app? So if we go here and we take a look, I'm setting up my CSS for my buttons, or my single button, and we scroll down, we're creating a polygon layer. So this is the layer that's actually targeted by all these geometry saves. So we're creating our polygon layer, we're creating the graphics layer that Sketch requires on the client side to actually display those graphics. We'll create our map, add both of those layers to the map, create our view using the map. When the view finally loads, we're going to set up our Sketch View model. We're going to pass it a reference to the graphics layer that it's actually going to use to draw these graphics on visually, and we're going to pass it a reference to the view. So what's really important here is we're looking for when the user finishes drawing, that's really our target. So we can listen to particular events on the Sketch View model, and in this case we're listening to the create event. The create event will fire anytime you're clicking, moving the mouse, any sort of thing when you're interacting or drawing something. It gives you a lot of information. And based on the state property, we're looking at when it's complete. So we only care when the user is done drawing in this case. So when the user is done drawing, we'll take that graphic that they've just created, we're going to remove it from the graphics layer. So we don't care about it anymore. It's the responsibility of the polygon feature layer to display it after it's done refreshing. So once we've removed it, we call polygon layer.apply edits. That's the magic that adds it back to the service. We pass in our add features array, and you're good to go. Using that, you can pass in multiple graphics. Sketch really only provides the ability to create one graphic at once, since it's that kind of default workflow. So when we scroll down here, we can see a few other things. We set up our click event for our click listener for our polygon button. What's really important is you refocus the view after you selected a button in the UI, because view events require the view to be focused to fire. So if you were to go ahead and click that button and then click the view again, it's not going to do anything because that first click is actually refocusing the view. So this is like a shortcut. So as soon as I click my button, you can automatically interact with the map immediately again. So, and this little snippet down here is more of a shortcut that has nothing to do with Sketch per se. So this is setting up a click listener on our view. So when I click the view and I'm holding the control button, I'm going to run a hit test on that click event. And what it's going to do is it's going to tell me in the response if there's any graphics where I just clicked. So we're going to say, okay, we're going to look at our response, check our results. If there's an actual result in there, we're going to do apply edits, and we're going to delete the feature I just control clicked. So just to demonstrate again, I'm going to control, hold control, click the feature. As soon as the service reloads, it's gone. So just a really simple shortcut workflow there. You know, maybe you don't need the widget, but you can still interact with these graphics in a really simple, focused application. So that's our first app. We're going to take it a step further and actually use the widget. What does it take to hook this all up with the widget? So now looking at this, you can see our sketch widget interface in the top right corner. I can do things very similarly. Create polygons out of the box, polylines. We can update them, move them around. We can transform them, reshape them. We can do rotation here. And we can also do deletion. What's really cool is if I delete, it's gone. And you can do things like multiple selection, right? So I'm selecting this polygon. I'm going to shift click and select the polyline. We're going to delete both simultaneously. Cool, that's neat. Really simple now. So if I go ahead and delete all these big polygons and we refresh our app, all those polygons are going to be gone because they're on the feature layer side, right? So we don't see the big circle anymore. We don't see those things there. So going back here, we're going to look at this. And actually, we can just so you know, you can open up the network console. If we do this again, refresh, clear it out. We're only interested in apply edits here. We can go ahead, select these two guys, delete them. You'll notice that there's an apply edits call for each feature. You can optimize that if it's the same sort of geometry type into one call. And I'll go into why I'm actually using a different apply edits call for each feature in our sample here. So similarly, not to reiterate, we're going to create our graphics layer. And here what's different is we have to set up 3 different layers. So Sketch Widgets provides the ability to create points, lines, and polygons out of the box. And as you know, or you don't, you can only save one geometry type per feature layer. You have to choose a point, line, or polygon. In this case, because I want to have the ability to update all 3 of the things at the same time, we're going to create a layer for each geometry type. They're all part of the same service here. So we create these, and we're going to create our map. What you'll notice is I didn't actually add these feature layers to the map. So we're going to rely on the graphics layer then to handle the displaying of all of our features. So we set up our view. We use view.ui to add our sketch container, our widget, to the top right of the screen. So it's nice and responsive there as you move and resize the screen. We're going to set up a reference to our feature layers so we can easily loop through them. And we're going to add graphics to graphics layer. Now what is this doing? So this is actually creating a query for each feature layer, and we're going to query all of our features on each feature layer. We're going to get a response, get all of those features, and we're going to apply a symbol from the layer's default renderer. So we're going to use the symbology that the layers have predefined on them instead of setting up app level symbology. You can do that though, right? So you might have symbology on the server side, but you want your app to have really specific symbology. You can customize it here. And then once we loop through those, update our symbols, we're going to add all of our features to the graphics layer. Now I had a really good question yesterday in the first time we gave this session, and the user asked, is this a typical workflow? No, especially when you're dealing with feature layers that might have hundreds of thousands of features, it's very taxing to actually query and loop through all those and then re-add them to the graphics layer. This is simply for this demo showcase. It's a lot easier to just deal with these graphics on the graphics layer. Typically, you would leave them as part of the feature layer, and much like the other sample, you would set up a click event listener on the view, and you'd get a reference to that graphic, you'd remove it from the associated layer, add it to the graphics layer, and then pass it to the sketch view model. That's the more typical workflow. In this, it's just it's a little bit easier to see what's going on in this application, but I just wanted to clarify that. Because I do not recommend looping through all your features and then adding them to the graphics layer. I mean, if you have a really focused app, sure, go for it. But again, you might have 100,000 features. You really don't want to be doing that sort of thing. So we're going to go back up. We added all our graphics to the graphics layer. So great. So now all the features on these 3 layers that exist now are candidates for editing via the sketch widget. So again, we pass our layer and our view to our sketch widget. And similarly, we're going to set up a create event listener for Sketch, and we're really concerned here with when we're done drawing. So what happens? Okay, we're done drawing for the first time. We're going to go to update feature layer. We're going to pass a reference to the tool that we just used to create our feature, whether it's a point, polyline, or polygon. And we're going to pass a reference to the graphic that we just created. So in update feature layer, what's happening? So if we go down to update feature layer, we're checking the tool we used to identify the associated layer that we need to use to save our geometries. If we use the point tool, obviously we need the point layer and so on and so forth. So we identify what layer we need, we pass our edits, and we're good to go. So once we're back here, and as you can see, apply edits to layer, what that end up doing here is calling layer.apply edits. Now with here, you could do things, you know, with promise chaining, with .then, .otherwise, .always, to handle error states, display UI messages, display loading indicators while it's waiting for the service to save it and update. For simplicity's sake, I left that out of the sample, but you can imagine there's a lot of power there as you're waiting for the service to respond. So going back up, we're done with our create. So we handle when the user creates a new graphic. So we also have to handle when the user updates a graphic. So similarly, we listen to the update event and we check the state. When the user is done updating, whether it's resizing, scaling, rotating, we listen to when it's done. And we have to loop through all of the graphics that you're updating. So unlike create, we can only create one graphic at a time. Well, for updating and deletion, you can update multiple things at the same time. So we have to handle that case here. And like I said earlier, you can update multiple graphics, but they don't have to be the same type. So you saw me select a polygon and you saw me select a polyline. We need to know, obviously, which layer each of those belongs to. We can't just make a blanket assumption and go with that. So that's what this loop here does with graphics for each. We're checking the graphic, we're checking the geometry type, and passing that as the tool, right? So it would be point, line, polygon again, and we're passing the associated graphic to our update features. I could have been a little bit more clever. I could have checked if all the types of all the graphics in the array were the same, and then I could have used one single apply edits call to consolidate and optimize my application, right? But for just this demonstration, we're just going to loop through and do an individual apply edits call per feature. So similarly with delete, same sort of workflow. We need to get all of the graphics. We're going to loop through them, find out the type of the graphics I'm deleting, and update and call apply edits where appropriate. So this is, you know, just a really simple way you can get your sketch widget up and running and connected to a feature service without too much extra stuff there. So the last two samples I'm going to talk about, demos I'm going to give, are more focused on app level workflows. So this first one showcases two different tools at the client level. We have a cut tool and a flip horizontal or flip vertical tool. Now users have asked when, you know, we're going to hit feature parity with 3x editor. 3x editor provides a lot of different mechanisms out of the box for unioning geometries, cutting geometries, getting the difference of geometries, and I will say those are coming soon in the next several releases. In the meantime though, if that's something that is really preventing you from, you know, switching over and utilizing this stuff, it's actually pretty simple to set some of these operations up using the geometry engine. So that's the point of this sample. So what I'm going to end up doing is I'm just going to end up drawing some polygons here. Maybe we'll do a circle here, and maybe we'll do a line over here. So I'm going to take my cut tool now. I'm going to activate it, and I'm going to draw a line. So when I click to finish, we're going to cut all of these features. So all of these features are now individual features on the client side. So this sample doesn't use apply edits, but you can imagine, similar to the other two samples, you could wire this all up to pass in your new geometries. So you'd have to delete the old one, pass in the newly resulted geometries. So as you can see, I cut all three of these shapes into pieces, and that's great. You know, that's great. Okay, so maybe more simply, this tool requires you to actually have something selected and the widget to be active in the update workflow. So if I go ahead and click flip, it's just going to flip the entire geometry upside down using the geometry engine. Same thing in either mode. So little simple tools that maybe you don't necessarily you know, want to wait for, you can implement yourself. So let's take a look at how I'm actually doing this under the hood. So if we open up a custom tool sample, very similar logic as the last two, I'll kind of skim over it. Graphics layer, map, view. So the first thing that kind of sticks out is I'm storing this variable called cut active to false. So what that's doing is when I click my button, I want to know that the cut tool is essentially active, so I can do some special things in our sketch event handlers. So looking down, we're going to add our button containers and widget containers to the top right of our app, create our sketch widget, and we're going to set up a create event listener. So Oh, I should take a step back too. I should have mentioned this a long time ago. Franco's application was done in TypeScript. This is all JavaScript. This is more of our typical SDK examples, right? So we do everything in JavaScript, but you could also do all of this in TypeScript. We just wanted to showcase you can do it either which way. It's really up to you. Okay, so back to the action. So we're going to check when we're done creating something, and we're going to check if cut's active, because it's going to indicate that we just finished creating our cut graphic, right? So we drew our line, we cut something, and we're going to update our state. We're going to say we're not cutting anymore. We're going to remove the cut graphic, the line we just drew from the view or from the layer. And we're going to get a reference to all the graphics on the layer that we're targeting. So why we're going to do that is because we need to know what graphics we're going to cut. We need to test if these graphics are candidates for cutting. So we loop through our graphics, and we get a reference to the graphic and its geometry. So using the geometry engine now, we're going to call geometry engine.cut. We're going to pass in our graphic candidate, our cut candidate, and the actual cut line's geometry. So we pass in both geometries, and we get our result set here. So within cut geometries, it's an array result. You know, maybe you passed in a line that intersected the feature multiple times. It's not just, you know, you can't, it might create more than just two pieces, right? So if you're cutting a polygon, you might end up cutting into eight slices for whatever reason, right? So we need to account for this. So as long as we have some valid cuts, we're going to loop through those, and we're going to create new graphics based on the resulting geometries. So here in this loop, we're looping through those. We're going to use the same symbol that the original graphic had for consistency. And we're going to remove the original graphic that was just cut from the layer because it is no longer valid. It is obviously cut into different pieces, so we don't need it anymore. And then after that, we're going to add all our different pieces back to the view, or the layer. So what is actually going on here with the buttons? Very similar. We're just setting cut active to true when I click my cut button, and we're going to use Sketch, the widget itself, to create a polyline. So that's why in the event handler for Sketch, I can actually use the Sketch widget in its own for this specific tool. I don't need to bring in like a whole nother Sketch view model to do this and keep them all separate. This way, it's a lot easier for stateful application management here. So what's happening with this flip button? A little bit different, a little bit more complex, because it requires the Sketch widget to be active. So we want it to only work when the Sketch widget actually has some targeted graphics. You've selected a graphic, it's in that bounding box mode or that reshaped view, and you're actively updating it. So we're going to verify the tool name, transform, reshade, or move. Those are the three states with our update tool. And we're going to get a reference to all the graphics that we're currently updating, whether it's one, whether it's multiple, it doesn't matter. And we're going to update the geometry of each graphic individually. So we're going to loop through, use the geometry engine again, and we're just going to call flip vertical. Pretty simple stuff. You can imagine you can replace this sort of thing with any of the methods within the geometry engine. You can create a bunch of different custom tools. You can probably imagine, using the rectangle tool, I draw a bounding box. Let's union all the geometries within that bounding box. So this is the kind of workflow that you would need to do that stuff. So here at the bottom too, this is kind of important here in this way. So we're going to call update on the graphics we just recreated or cut or flipped in this case. So we're going to use the widget and call update again, and it's going to reactivate the update workflow using the tool that we had just previously used. So it's going to just stay active essentially instead of finishing itself. And then we refocus the view when we're done. After we click the button again, the view needs focus to fire events. So that's our sample for cutting and flipping, and we have one more. And this one is more focused on geometry validation. So both validation and snapping, right? So they're similar in that we're modifying the geometries based on something that we want at the end of the day. So this sample is also using geometry engine. And right, what I have is a point that shares a vertex with this polyline, this nearly circular polyline. And what I'm doing is I can grab this point, and as I drag it, I'm forcibly making sure it's always connected to the polyline using the geometry engine. So I'm using nearest vertex or nearest coordinate. You can use either. well, its nearest coordinate, nearest vertex, you would only get the vertices at the end of each path. So for the smooth animation, I'm using coordinate here. So you can imagine it's another example that you could use this in a real world application. Trains and railways. Maybe you have all your railroad routes laid out with polylines, and you want to do some slick animations or slick snapping with train graphics to represent real-time train. Train schedules or whatnot. You can drag the trains and they'll be snapped to the track. Things like that. Boats in harbors. You don't want to clip into the land. You only want to you only want boats to remain in the water. Those kinds of validations you can use snapping or geometry validation. So the other ones here, we'll zoom in a little bit. So I select my polygon, and this guy, I don't want to move outside this bounding box. I want the geometry to only remain in the bounding box. So once we hit this edge, we stop updating this bounding box, and you kind of see this like floating yellow ghost polygon representation of it, right? So that's kind of to help indicate that, hey, this is kind of where it would be, but it's not, it's invalid. So we're going to prevent it from actually updating. So even if I go out here, it's done, right? Similarly, this one can't overlap, can't be within the bounding box. So you can go both directions. They're very, very similar in their execution. So let's take a look at what I'm actually doing here to get client-side snapping and geometry validation going under the hood. So just kind of skim over some of this stuff. So what I'm doing here, part of what I mentioned earlier, so any graphics that are assigned to your graphics layer that you pass to Sketch are candidates for updating. So maybe you don't want to be able to update every single graphic in your application or in your view. In particular, looking back here, I don't want to be able to click the bounding box or the big semicircle and update them, right? I don't want, that's not the goal. I only want to update these 3 green graphics. So I'm going to actually use 2 different graphics layers. I'm going to use a background graphics layer is the name I chose, an active graphics layer. So we're going to put our bounding box and our circle on that background graphics layer. Sketch has no reference to them, so clicking them doesn't actually do anything. We're going to add them both to our map, create our view. Some of this stuff is just setting up symbology unique to this app. Nothing too fancy, just simple fills, some different symbology for displaying like different states. So in particular, that dashed polygon line is one of these defined here with dashed fill. So when the view's ready, we're going to create all of these graphics on the client. So this is all hard-coded here. We're going to create our polyline. We're going to create our point that shares a vertex with our line. We're going to create our bounding box container. And we're going to create our 2 polygons, the inside and outside polygon as named. And we're going to create graphics based on all of those symbols and geometries. So here, this is really what is really tricky part of the app. So what I'm doing under the hood is I'm creating a clone here. So what is this clone? What is this? This clone is actually what represents the validated geometry. So when I start moving something, I create a copy of that graphic, I hide the graphic that you're dragging, and use the clone to represent the valid geometry. So if we validate our geometry, I'm going to update the geometry of the clone. And then when you stop moving, it'll grab the geometry from the clone, reassign it back to the original one, and redisplay it. So it's kind of a neat little thing there. Here, sorry. So step back, sorry. So with our sketch view model, we're going to pass in our layer. We're going to set specific tools here. We're going to just only the move tool. We're going to set it so I don't have, I'm unable to move all graphics simultaneously if there's multiple selection. And we're going to update, we're going to use a custom point symbol to make it a little bigger in our app, because otherwise it's pretty small in this sample. But we're looking at our update event now. So when I'm actually done updating, this is I've grabbed the graphic, I've started to move the graphic, or it's actively moving. We're going to store the information about my movement. So we're going to get the information about the move tool, and we're going to get the graphic that is actually being moved with toolinfo.mover. That is the graphic. So what also is that graphic will represent, if you have multiple graphics that are selected and moving, that mover property will give you the actual specific graphic that is being moved. So we're going to look at here. We're going to when we start moving our graphic, when we at the very start, before we've actually moved it, we're going to create that. We're going to assign the clone. add the clone to the background graphics layer. And in the snap graphic case, which is the point that's attached to the line, we're going to hide that guy and return here. So we're not going to do anything else. But for the polygons, we're actually going to change the symbol of the original graphic to that dashed yellow symbol. So going back to the app, just to give a better visual representation, I select this, and as soon as I start moving, the original graphic, we create our clone, we assign the clone, and it's that dashed yellow fill. So I'm moving the original graphic, which is the yellow one. The clone is actually the blue graphic that you see here. So we only update that clone's geometry when its return is valid. So you can kind of figure it's a little trick to give a little bit more visual feedback, because I wanted to be able to keep moving this geometry without it having being locked in place. It's a little jarring if you do it a different way, where you might run into an issue where you try to drag it, but then how do I describe this? So when you're moving it, if you override the geometry of the graphic that you're moving, you can run into cases where it feels very unresponsive and almost like it'll zip around the screen and weird, unsmooth behavior, not very smooth at all. So this is kind of gives that illusion of, hey, I'm still moving it, but it's invalid, right? So going back here, so what's actually happening when I'm moving? We're using geometry engine.nearest coordinate, passing in the snap line, and our graphic.geometry. Our graphic is our snap graphic. So we're passing our point and our line to the geometry engine. We're saying, hey, give me the nearest point on the line, and then we can update our clone's geometry with that nearest coordinate. Similarly, for the actual polygons, the logic here is similar. We're using the geometry engine.contains. We want to make sure that this inside polygon is contained within the container. So only when contains returns true, we're going to update our clone. So whenever that graphic is outside of the container, we're not going to update our clone, so the geometry is not going to get updated. Same sort of thing here, but instead of just using contains, we're using overlaps as well. And we're using the opposite. So as long as it doesn't contain and it doesn't overlap these geometries, then the geometry is valid. In move stop. So we're done moving. We have to clean up. We have to kind of like take care of our clone. We have to resync all the applications. So what needs to be done? In the points case, we need to make it visible again. And in the polygon case, we need to we're going to get the original symbol from Sketch View model, because we updated it to that yellow dashed symbol. We're going to change that symbol back to the original, and we're going to run the same sort of operation. We're going to verify again that the geometry is valid and update our clone here, if applicable. So cool, we've updated our clone, and we're going to finish now. So we're going to take the stored validated geometry that's on the clone and assign it back to our primary graphic. We're going to remove the clone and set it to null. The clone's gone. So it's this kind of like stateful storing of geometries, validated geometries on this sort of clone that we can use after the fact. So what's nice about that is, because we're not modifying the geometry of the graphic that you're moving, you can use that. You have a reference then to the original invalid geometry that you could use for other things, right? Doing error messages, other validation. You could also store that at the app level, but it's just really nice to have both the invalid and the validated geometries in two different ways that you could do other things with. So that's the sample with very basic snapping and client-side validation of your graphics. But with that said, built-in snapping is coming soon to the Sketch widget, and it will be inherited by the editor widget in the typical 3x experience, right? So you might hold down Shift, and depending on how you configure this, you'd be able to snap as you're creating, updating, without having to do things on the client side. But maybe that's not for you. Maybe you have a lot more specific validation there with your snapping. You can do a lot more here, specific layers, specific features, that sort of thing. I think that's it for my demos. So pass it on to Bjorn.
Thanks, John. So we took you guys from the two-line web editing using the editor sample to the custom workflow with the feature form, and then showing you how you can write code for even snapping and validation. So from very easy to very detailed. If you like us, fill in the forms. And this is where the URL for where you can get this slide deck with all the samples. If you didn't take any pictures of anything else, I recommend this one. And, well, some people do that. Any questions?
What's in 4.10 now is being added in 4.11, what it just showed?
So the question is, what was in the 4.10 release, what's coming now and later? So basically, the editor widget that I was showing is coming in 4.11. Everything else, more or less, is already.
95% of it is already in 4.10, so a lot of the Sketch things. We made some quality of life changes, but really minor in 4.11 for Sketch. So adding things like different shortcuts. So those are some of the things that we didn't talk about, is like these built-in shortcuts with Sketch, right? You can undo and redo with the keyboard or via the interface. There's a lot of flexibility there. And we really want to do a better job of exposing keyboard shortcuts in particular, because you can do things like holding spacebar to lock it while you're drawing, and it'll basically pause the drawing so you can pan the map. Otherwise, when you're in freehand, you can't really pan the map, because you try to pan, you grab and pull, you're drawing a line, you're not moving the map, right? So, so little things like that are coming to Sketch. Sketch is getting a lot more updates in the next 2 releases, though, versus 4.11.
Another example of what's coming to 4.11 in a few weeks is sketching in 3D. And then that's the beginning of the editing in 3D that's coming after that. Any more questions? Middle?
Feature form widget. If I like only to hide one field, but it's okay with all the defaults. I'm forced to list all other fields.
If you want to be able to hide just one field, you would list all the other ones for now.
The answer right now is yes. The reasoning is, as soon as you start to provide a configuration of how you want your fields to render, we just let that to the user.
Is there a way to look up the default field configuration?
Yes. So on the feature layer itself, you can get the list of the fields. So you could loop through that, and if you know that you always want to remove a specific one, you could do that.
And if you're only worried about, if you just want to make sure, if you just want to toggle the visibility, it's really simple, because it just requires an object with a name property.
Yeah. Another better solution is to not publish it that way. So while you have a feature layer with those attributes, you can, if you have using online or enterprise, you can have a hosted view, a view layer that only shows you what you want to show. Any more questions? There.
So for the ease of use, the organization is moving towards the web app builder, which has smart editor and all this functionality. So how we can justify like when to use the web forms or feature forms specifically versus what is already there in the smart editor widget in the web builder?
So the question is, if there's already logic in the FreeX API and including the web app builder that's based on FreeX API, and including some widgets like the smart editor widget. So what we're trying to do as we migrate into 4 is to support all of that. So you'll notice that some of the logic from the smart editor widget is now out of the box. So when the web app builder is based on the 4X, it's just going to inherit this. And there's less need for custom widgets in the web app builder.
So in other words, whatever is there in the black box behind smart editor widget, you are bringing it out in ArcGIS 4X APIs?
It's being completely rewritten, right? So even Web App Builder is being completely rewritten using the 4X API. They're going to be different products. So I mean, even with the newer Web App Builder, when that's slated to come out, that's going to be taking advantage of everything in the 4X API. All the optimizations in WebGL, 3D, I mean, little things like that. With the current Web App Builder, you're kind of stuck in that 3X environment. So you don't get access to all these new features that we've been working on for the last few years, right? So
basically, when we want to use this API, it's like kind of a lightweight application versus web app is like.
I think there's 2 questions that you have. One is, when would I use the JavaScript API directly, writing a custom app, and when would I use a template or the web app builder that Esri provides?
Right.
I think that's a separate question from the migration path of 3X and 4X, and one is 3 months earlier than the other one. If the out-of-the-box components things works, I think that's a great opportunity to just use that. If you want to do something custom, then there's multiple levels of where you can do that. In the case of the web app builder, you could have a custom widget. You can download the developer edition and modify it, or you can use something based on the API. And the same thing, it doesn't matter if it's 3X or 4X.
And I mean, like, the newer web app builder is going to be built using a lot of these tools as well, right? So it will end up using what we just showed you under the hood in the newer web app builder. So it does provide you the flexibility. They're going to put their own spin on it, obviously enhance it, extend it, do a little bit more because it's a specific focused application. But we're just providing the building blocks to build something like web app builder at the end of the day. So, but if web app builder works for you, obviously it's going to provide all that neat stuff that you don't have to write yourself. It saves you a ton of time, but it's using the same components, which is what's really cool.
All right. Sorry we went a little bit over, as did the lunch, but we're done now. Thank you very much.